Hello everybody, my name is Kevin. I live in the city of Echt and live in the Netherlands. For my final project I've worked on a implementation of Conway's Game of Life in C. During CS50 I noticed I personally really enjoyed the C part the most, so I wanted to learn some more about C, work more with algorithms, so I decided to implement Conway's Game of Life for this one. My main focus was, as I said, well, to learn more about algorithms, learn more about C, but also about makefiles. This project I mainly focus on creating my own little makefile. So if I call make, my project is automatically compiled and it creates valid binaries which I can run afterwards. I can also run make clean if I want. This will remove any binaries, make sure that the development area is clean. For now I'll make it just so I can show you the implementation of it for a second. Before that, I think it's handy to first look at the implementation a little bit. I've got four main functions really. The first one is print grid. This, as the name implies, prints the two-dimensional grid of the game's board. The user can decide how large or how small he or she wants the board to be. After that, we have count neighbors. This function, well, as the name also implies, counts the neighboring tiles and sees if they are already populated by a creature of some kind. If yes, it'll increment. If no, it won't. This input is now later used in next generation, and this will then check if the tile is empty, populated, or overpopulated, and will then in turn cause a creature to reproduce or to die. After that, the main function, which does a lot of the user input, handles the size of the board, and you can optionally say to the program how many iterations you want your simulation to run in. Now, well, the rest is just some arbitrary code and just running the simulation itself. The simulation can be run by invoking /game of life, giving a size of your board, and optionally how many generations you want it to run. For now, I'll just say that I want to have a board of 10, after which it will generate a random board. I can then step through the simulation by entering enter. And if I press Q, the simulation will stop. Originally, this was developed on a dual boot machine that was using Ubuntu, but I later ported it to code spaces to make recording a bit easier and that other people can also run this. This was my project, my final project for CS50. I hope you enjoyed. This was CS50.